Good day, class. In this lesson, we are going to talk about two types of velocities that are used to analyze the motion of our satellites and rockets. So we have the first one, the escape velocity, and the other one is the orbital velocity. So let's start first with the escape velocity. So, importante ning escape velocity, class, kay para may baon na to kung unsa nga velocity ang dapat i-achieve or i-attain sa atong rocket para makaikiyas siya sa gravitational pull sa atong Earth. So as you can see in the picture, gilaunch ni siya nga rocket. So kani siya nga rocket para mo propel siya or mo continue siya moving upwards, dapat iyang ma-attain ang gitawag nga escape velocity para di siya ma-pull back towards the Earth. So, very important ni siya, class, sa pag-design sa atong mga artificial satellites. So, remember, ang satellite day, class, the definition of satellites is mo na siya ang mga small objects nga ni revolve or may orbit sa usa ka larger objects, and satellites are not limited alone to our artificial satellites like kanang sa ISS, sa ato mga Apollo 11, etc. So makakuha po tag mga natural satellites. Unsa man na sila? Example, we have the moon and also the moons of the Jupiter and other celestial bodies. Even our Earth. Our Earth is a natural satellite nga nag-revolve around the sun. So, in order to understand or in order to get the formula for the escape velocity of our rocket or our satellite, so we need to derive it. So, in order to derive it, class, so ato sa i-illustrate ang system or atong ang interaction between our Earth and the rocket. So in this figure, magbase lang ta. Let's say this is the surface of the Earth. So kana siya. And then of course, let's assume that this one right here is the core of the Earth. Okay, that is the core of the Earth. And suppose, class, let's say naay initial position ang ato ang rocket. So before siya milupad, nagina siya gitawag nga initial position, and that we label that one as x sub I lang. So x sub I, meaning this is the distance from the core of the Earth towards the initial position. So initial position. And then again, our object to be studied is the rocket. So ang rocket. And then we label the initial position x sub I, so okay na. And then of course, it will go upwards. So it will go upwards. So we don't know kung asa siya kotob. So let's just assume nga may go siya or may travel siya at a certain distance from the center of the Earth sa core towards x. We don't know kung unsa na ang value sa atong x. And then take note, class, nga at the surface of our Earth, ang distance ano towards the core, of course, we denote that one as r. So ang r, class, is the unsa man siya? R is the radius. So r is the radius of the Earth. So radius of the Earth. What else? So I think wala man na. So mara atong kinahanglanon in order to derive the formula for the escape velocity. And aside from this, class, of course, since we also have forces that interacts our rocket, so napod tay ay considered nga iyang FBD. So we draw the FBD. So FBD. So the free body diagram, class, will look like this. Let's say this is in terms of terms of the forces. So in terms of the forces na may interact sa atong rockets. Suppose man itong rocket represented by this point. So unsa may nagpa kuan niya, nagpa bira niya outward. Of course, we have the gravitational force nga nag-interact nilang duha. We denote this one as Fg. And then of course, napoy force due to the acceleration due to gravity or the weight, and then let's just denote this one as Fw. So summation of forces, on the vertical must be equal to 0 para in a dynamic equilibrium ni siya, since nag-move man ni siya. So here we can say that the gravitational force G is just equal to the weight of our rocket at a certain height sa iyang pag-travel. So we know that the gravitational force is just the gravitational constant G, then the mass of the earth, then the mass of the rocket O. So ato rin butangan diri para di ta maglibog, ME, the mass of the earth, then MO, mass sa atong object, or here rocket man ta, so mass of the rocket. So G, ME, MO all over the distance. So kung asa na siya dapit ang atong rocket. So here let's assume nga at point X siya, at a distance X. So we don't know asa siya dapit, so let's just say that is X squared, that is equal to the formula for the weight is just the mass of our rocket, MO, and then of course the gravitational constant at that height, G of X. So we cannot say that this is equal to G, which is equal to 9.81. Remember class, ang atong G is the acceleration at the surface of the earth. So di ba? So ako lang gidino diri nga MOG of X kung unsay kuan, kung unsa nga height. So mo na siya ang general formula for the relationship between the gravitational force and the weight of the rocket at a certain height X. So X mo na ang height of the rocket. Okay, so this is now the forces that interacts our rocket. Let's assume ng class. So assuming nga si rocket is located on the Earth's surface. So on the Earth's surface, what would be our relationship between the gravitational force and the weight of the rocket? So if that is the case, so therefore our X now is equals to R. Why? Kaya on the surface man. So diba ang distance na nato from the core of the Earth towards the Earth's surface is just equal to R. So replacing that one in our previous equation, we now have G, then ME, MO all over R squared is equal to MO, and this time our GX na is equal to G, which is equal to 9.81 meter per second squared. Mo ni ato ang naandan nga value sa atong G. So here we can also derive a relationship between the gravitational constant and the mass of the earth is just equal to this one is G. So this one will be cancelled out, so makancel ba ni diri. Therefore we have now G R squared. So remember this one, this is equation 1, because we can use this one sa atong derivation. So nalatay derivation sa ato ang forces. The next one is, since ang formula mo good class sa mga forces ari is we don't have the velocity V. So di pa ta kakuha sa escape velocity, but we have another formula that contains the variable v, or the velocity. So we are going to use the energy equation. So since nag-move man siya, in order to escape the gravitational pull of our Earth, ang rocket nag-move man, so kung sa may energy nga nag-associate sa motions, that is what? Kinetic energy. So therefore, we can say that the kinetic energy is equal to 1/2 the mass of the rocket O, then the velocity, or we can just denote this as VE, or the escape velocity. So muna yung kailangan, class. Muna yung kailangan ng VE, which is also equal to ang sum na siya. Now, since namatay energy, kay in motion man siya, equal lagi po na siya sa ansa man ang iyahang work, or the displacement work. Equal na siya sa displacement work, since naman siya displacement nahitabo, since may travel man siya at a certain distance. So we can say nga we have force, the driving force, times the distance. So let's assume nga we don't have a definite distance, so we let's just denote that one as dx. Okay, so that is equal to force times dx. Muna iyang displacement. So patakaybaw kung sa. Okay, ang force nga nagpa-move niya outward, di ba? Recall, the force that enables a rocket to move outward is just the gravitational force, Fg. So this is Fg, and then we all know that Fg is what in terms of x. So therefore, since this is dx, we need to what? We need to integrate this. So therefore, the kinetic energy is just the integral of our f dx, starting from, of course, the initial position of our rocket, that is x sub I, until what? Infinity. Why infinity? In order to escape the Earth's pull. So what ba? Until pagid nga mga to na siya sa kuan, as long as makaikyas gid siya sa pull, manang we assume this one, that the total work until infinity, walay kahumanan. Kay don't worry if ato nag-assume nga wala siya kahumanan, meaning sure naman gid ni nga makalusot gid siya sa Earth's gravitational pull. So here we use integration, then we substitute the value of our force due to gravity, the gravitational force, that is equal to G massa Earth massa rocket all over x squared dx from the initial position until infinity. So we can extract the constant outside. So we now have G me, then mo, wala hindi over kay wala na may, hindi mo na ma-extract ang x, since x is the variable. And then pwede po na ito ma-bring sa numerator si x squared, mahimo siyang x raised to negative 2 dx from initial until infinity. So this is equal to GME MO, and then power rule plus ang integral of x raised to negative 2 is just equal to x negative 2 plus 1 all over negative 2 plus 1 from xi to infinity. So this is GME MO, then that would be x raised to negative 1 all over negative 1, or that is negative 1 all over x na lang. Kay negative 1 man siya sa babaw, so ito nang i-bring down sa bus para positive ang exponent. Then starting from xi to infinity, then substitute class GME MO, the initial value is 1 over infinity, then minus negative 1 all over xi. So we all know that 1 over infinity is 0, so ma-0 na siyang apart. So the final answer pala is just equal to G ME MO all over, kani siya ma-positive na, so that is all over x sub I. And then since mao na ang total work, so we can ato na siya ma-equate sa atong kinetic energy, which is 1/2 the mass of the object times the escape velocity squared. So common naman ang mass object, so mara lang na, and then multiplied to both sides. So that is the escape velocity squared is equal to g me, that is 2g me over x sub I. Taking the square both sides, that is the escape velocity is just equal to the square root of 2g me all over xi. So kung unsay initial niya nga position, mao pa na imo substitute ari. So therefore we have general formula for escape velocity VE is equals to the square root of 2g me all over xi, wherein the xi is the initial position. So let's say class, let's say ang case number 1 is above the earth or above the surface of the earth. Above the surface. Let's say na siya height nga h. So what would be the x sub I? So that would be VE is equal to the square root of 2, that is not g nga small, capital ni siya. That is 2g me all over, that is the radius of the earth plus the height from the surface of the earth. So wala siya kung ang initial position niya is at a certain height h. So naman itibutan tayo a certain height h. But what if class, what if unknown, wala kakahibaw sa g og sa mass earth? So for case 2, how about unknown or wala jud kakahibaw sa g and me or the mass of the earth? What will we do? Do we still have another alternative formula for our escape velocity? Yes, because remember sa atong kuan kani siyang equation 1. So from equation 1 we have relationship gme is equals to gr squared. So from equation 1 we have gme is equals to, that is g r squared. Asa may tabo? At the surface mo na siya, diba? At the surface. Okay. So balik sa ato ang general formula, that is VE is equals to the square root of 2gme all over x sub I. So again man nga, kung nagsugod siya sa surface of the earth, or I mean out niya lang day. So ang kailan sa atong nahon kaning GME, di ba ang GME is just equal to GR squared. Kay mao man nato nakuha sa equation 1 pag derive nato kung ang object kay naa sa surface of the earth. So therefore ang equivalent rin sa GME is equal to the square root of 2, then that is GR squared all over x sub I. Now kung mag-start ang ato, if the initial position, so if the initial position is at the surface, so at the surface of the earth na siya, at the surface of the earth. So kung naa siya sa surface of the earth class, so kung naa siya sa surface of the earth, unsay mahitabo? So ang mahitabo ani is mahimo na siyang kuan. Mahimo na atong x sub I is equals to r. Kaya the surface man siya. So therefore, mahimo din siyang square root of, mahimo siyang 2g then r squared divided by r. That is just equal to the square root of 2g r. So unsa man siyang formula kung naka sa surface nagsugod. So unsa man yung mga actual cases ani kanang sa SpaceX nga ilang paglupad silang Falcon Heavy 9 or other rocket sa NASA, di ba ang platform ana nila ang ilahang kanang kuan, ang ilahang kanang unsa na, ang kanang magpalupad sila sa ilahang rocket, diba, kay naman na ang pad ana kay naman sa surface of the earth, so therefore pwede din siya magamit nga formula 2gr. So mo na inyong tigaman. Again, this is the general formula. If you know the gravitational field constant of the earth, so I mean not the earth, the G is the universal gravitational field constant. Applicable na siya in other celestial bodies. So kung ang atong reference frame or the reference celestial body is ang earth pa ibutang diri. But if ang atong reference kay naata sa Mars, so Mars pa ibutang diri ang mass sa Mars. But ang value sa G is magstay the same kay universal gravitational constant maning G. Any object man na siya sa universe. And then, sir, how about sir kung ang kani sir wala ta nagbase ba? How about di ni siya at the surface? Unsa gamiton nga formula ninyo? Unsa alternative? So you can also relate that one as G ME para gana sa gibuhat, that is equal to G then X squared. So again, kung asa na ang location mag-vary gining G ha. So kung naka sa location nga X, acceleration due to gravity pud ana at certain location. Mao nang dire siya at the surface, atong gigamit is G. Tungod kay atong gigamit nga distance kay r man, which is the radius of our earth. So nga na gina para di ta makuan, so numdumi lang ni this, just remember the general formula. Again, from the general formula class, kung nagsugod ta sa surface of the earth, imo na ilet ni kaning x sub I or the initial position is just equal to r, the radius of the earth. Okay, so let's proceed to the second one, the orbital velocity. So ang kaning orbital velocity class is mao ni siya mao na siya nagpa-maintain sa satellite para mo-orbit siya sa earth. Kay kung di na niya ma-maintain ng kanang motion niya, kay naman ang requirement pud ani is the velocity. So kung di na niya ma-maintain niya yung orbital velocity, meaning mahagbong gyapon na siya pabalik sa Earth's surface. So unsay principle nga naa ni class behind? So since the satellite is in orbit of the Earth, so meaning na siya gitawag nga circular motion. So circular motion. So ato ra diri remember ang duha ka types of circular motion. I mean the forces nga nag-interact sa circular motion. We have the centripetal force, and then the other one is the centrifugal. Okay, so in order to derive the orbital velocity class, ato lang ikuan ang ilahang FBD, ang interaction nila. Diba we all know, let's say kani ang satellite, then unsa man nagpabira niya outward para di siya mahagbong ug balik, so natin gitawag nga centripetal force. So force centri alin ang himpul pud niya pabalik is of course ang iyang weight W, or unsa man the FG, or the gravitational force. So from this FBD class, we can say that the summation of forces along vertical is equal to 0 para ma-maintain niya iyang dynamic equilibrium nga state. So what are the forces nga ma-interact diri? So since class di man siya di man siya addition kaning weight or FG, ang pasabot ng class is we have the centripetal force F centri is equal to the weight at that particular distance, which is also equal to the gravitational force. So assuming class nga mo na center sa earth, so I think di maklaro, so gamit na lang taog heavy nga color. So kung itong pilihan. So since man assume ta nga man ang center sa Earth, sabta kay di gyapon maklaro kanina ta. And then ang distance gikan sa satellite padung sa center sa Earth aton siya i-denote as r, or the radius sa orbit, or the orbit radius na lang ana r. So therefore ato na i-substitute sa ato ang kanang equation area. Okay, by the way, we're going to use the red color one. So we all know nga ang centripetal force class is just the mass of our satellite. Let's say that is MO. Ato lang i-denote nga MO. Then the square of its orbital velocity, VO squared. So diba kay naaman ni siya dire velocity. Naaman ni siya orbital velocity. Unsa man ang orbital velocity? Unlike sa escape nga ang escape kay diba padungad to. So mo na ang direction sa escape velocity. Ang orbital is pangadto na siya class. Tangent siya sa kuan. So mo na siya ang VO, the orbital velocity, which is tangent sa iyahang orbit. Okay. So balik ta sa derivation. So we have MOVO squared all over sa to kung sa centripetal, that is over the distance from the object to the fixed axis. So here that is equal to r, which is equal to the weight or the gravitational force. So mag-start sa gravitational force. So that is equal to G, then the mass of the Earth, kay Earth man atong reference nga celestial body, then the mass of the object all over the square of their distance. So that is r squared. So we can also multiply both sides by r over MO. So cancel naman ang duha. So we now have orbital velocity squared is equal to, that is G ME all over r. So usa na lang ka r, then square root both sides. We have VO is equals to the square root of G ME all over r. So take note, r here is not the radius of the Earth, but the radius of the orbit of the satellite. So again, mo na siya ang general formula for our orbital velocity. Mo gani, always remember this one, class. However, naman gyud some cases nga unknown, or wala ta kay baw sa, let's say wa ka maray sa universal gravitational constant o ang mass pod sa usa ka celestial body. So what will you do? Or wala po ka kahibaw lang sa Earth, sa ibatan nimo. So you can also derive another kanang parameters para ma-substitute diri sa atong GME. Okay, so we all know that from the summation of forces along vertical, naabot tayo sa relationship between the centripetal force, the gravitational force. Diba naabot tayo relationship between the gravitational force Fg, which is also equal to the weight. So we'll know that the gravitational force is G ME MO all over, let's say we don't know the location, so mo nang gibutan natong r dra. R squared is equals to the weight is just the mass of the object times the gravity at that r. So again, di ta mo gamit atong G nga purely G ha, kay ang G ato is magamit ato at the Earth's surface. So since na naman tay distance, naka-distansya naman siya sa Earth's surface, kay ni orbit na gud siya, satellite naman niya. So therefore lahi na ta og value sa G. Mo na akong gi-denote diri nga GR. So mao na siya, and then ma-cancel out ning M. So therefore naatay relationship nga G ME is equals to GR times R squared. So diba? Unya, pwede po na ito ma-substitute. So therefore, ang ato ding VO na is equal to GR then R squared all over R. Or, masimplify pa na, may muna siyang GR then R. Mao lang. Pero, kung maglisod dag pangita gid sa GR, kay mag-agad man na sa kuan lagi. Mag-agad pud sa R. So, ang ato lang naibawan mo gud kay ang G ra. So, can we still find way para ma-G na lang ni siya? Yes, we can kuan man, maka-equate man ta sa gravitational force which is equal to the weight asa man. Let's say at the surface of the earth. Diba? Namatay at the surface of the earth. Namatay relationship nga G, M, E, M, O all over at the surface naman of the earth. So, kani siya mahimo na siyang unsa man R, small letter R squared is equals to mass of the object times the gravity. So, let's assume nga R is the radius of the earth. So, therefore, ang atong GME na karon, so, GME is equal to G na gyud nga 9.81 times the radius of the earth squared. So, ato na i-substitute atong orbital velocity, mahimo na siyang VO is equals to square root of, mahimo na siyang G R squared all over R. Let's say at a certain distance from the surface na ang kuan ang satellite. At a certain distance h from the Earth's surface. So, unsa naman pud ang formula ana? Ay mo substitute nga ang R is equal to the radius of the Earth plus that distance. So, therefore, ang VO is equals to the square root of G then R squared all over R plus H. So, mara gini mo hinumduman ng mga kuan. Actually, giderive na po ni siya sa general formula. So, kani sila. Giderive ni aning general formula for orbital velocity. Okay. So, let's try to solve sample problems. So, here, problem number 1, if the radius of the Earth daw is 64 kilometers, so, given, i-denote nga R is equals to, that is 6,400 kilometers. The radius of the Earth. Then, and the acceleration due to gravity is given, so, G, natay G is equals to 9.8 meter per second square. So, at the surface na siya. So, at the surface. Calculate the escape velocity. So, required the escape velocity, that is VE. Okay. Since naman tayo given nga G og R, so, okay. Solution. Duha man itong given, G and R, so limited na kayo ta because from the general formula of VE, that is equal to the square root of 2G mass of the Earth divided by, ano to? XI, di ba? Since kani kay in terms man of GR, so kani siya class kay ni-assume ni siya nga distance ani niya is at the surface. Why? Because familiar man ta sa value sa gravity which is equal to 9.8. So therefore, we can say that here xi is equals to r. So, asa na substitute, that is mahimo na mangunsa. Makaibaw naman po nga si GM diri. GM is just equal to unsa man? That is G R squared at the surface. So, we have 2G R squared all over R. That is just equal to the square root of 2G R. So, naan ang duha. na ang duha ka given. So therefore pwede tayo maka-answer. So substitute the values, that is 2 times g is 9.8 daw meter per second squared. Then our r here is in kilometers, so ato pa na i-convert. So 6,400 kilometers. Then kay ba mo nga ang 1 kilometer is 1,000 meters. So simplify. That is the square root of 2 times 9.8 times 6,400 times 1,000. The answer is 11,200. So ang answer nato is 11,200 meter per second. So mo na nga ato ang escape velocity. So grabe no. Mo na ang escape velocity sa ato ang kuan sa earth nato. If kuan mo na ang kuan, actually ang approximate ra siguro ning 6,400 nga value sa radius sa earth. So mo na siya atong kinahanglan nga i-achieve kung let's say ikaw gusto ka molupad or atong rocket molupad. Starting ni siya at the surface ha, given nga ang kanang 9.8 kay mo na siya ang reading sa acceleration due to gravity at the earth's surface. So again magdepende ha sa height ang value sa atong g. So please don't forget that one. So mas better nga imo sa suwaton ang general formula for the escape velocity, then try to figure out nga unsay initial position ni ining problema kay exabay man ni. And then if we don't know the mass of the earth, if wala given, so therefore di po ka pwede makabutang-butang pataka-pataka. So be sure to analyze the problem kay naman tayo mga relationships gani akong i-derive, di ba kani this one is came from the gravitational force and the weight of the object at a particular height from the celestial body, or sa atong example guys sa earth. So yan na ra, be sure nga inyo na i-take note. So for the problem number 2, this is all about orbital velocity. So here it is stated that a satellite is revolving around the earth at a distance of 182 kilometers. So ato sa kuanan of figure and data. So natin tayo earth, then na-add ako na yung satellite ari, then na-revolve siya around the earth at a distance of 182 kilometers from the surface. So ano na siya dito sa surface, that is 182 kilometers. So naging na siya velocity, mo na siya ang VO, ni-revolve ko na siya dito ana. Okay, and then the radius of the earth is 6371. So kana siya gikan dira mo na r. So let's we denote r is equal to 6371 kilometers. Then ang g, okay, ang g nato kay 9.81. So kanang g arang value is at the surface na siya, g equals 9.81 meter per second squared. Kaya pong gi-indicate nga ang g ani kaning value nga g is at a distance of 182. So man, so therefore kana siya nga g kay at the surface. Okay, at the surface na siya. Then calculate the orbital velocity. So required the VO or the orbital velocity. So solution. So we can use the general formula. So VO general formula is equal to the square root of that is G ME all over R, the big R. So sa ng big R, mo na siya ang distance between the Earth's core or the Earth's center towards the location of our satellite. So this is now our R. And what is the sa may kanang kuan, and sa may value sa atong R, that is equal to the sum of the radius of the Earth and the distance sa satellite from the surface of the Earth. So since sa inyong calculator kay ba ka sa value sa G, but since the mass of the Earth is not given, so mangita tag mga relationship nga mohatag siya mga parameters nga naara sa atong mga given. So we all know class sa atong pag-derive sa previous pagid nga mga slides, we all know nga natay relationship between the gravitational force and the weight of the satellite at that height, and then that is equal to G ME MO all over R squared is equals to MO then G at R. So here, cancel na si MO, then we have GME is equal to GR then R squared. But here class, wala man tay given nga GR. Ang G naman at the surface. So therefore, dili ta mo relate ani ana nga height. Ato i-relate kay what if assume lang ta nga naa sila sa surface. So unsa may value ana sa FG and W at the surface. So at the surface na ni. Again, wala magwi given nga G at that height R. So at the surface, natay relationship nga GME then MO all over R squared kay the surface niya, the earth surface is equal to the mass of the object times the gravity nga 9.81. So here cancel na siya. So we now have GME is equals to G R squared. So therefore natay GMA ato na siya is-substitute ari. So natay escape velocity nga VO is equals to the square root of that is G R squared all over R. Then unsa man natong R? R is just equal to the R plus the height, di ba? Then substitute the values. So we have 9.81 multiplied by the radius of the earth that is 6371. So 6371 since ang kilometer na siya, ato pa na siya multiply 1000 para ma-convert into meters. Then both of these should be squared. Okay, ato na squared. Then ang R po dire, same thing, multiplyan po 671 times 1000. Then plus the height is 182 kilometers. So plus 182 kilometers, 182 multiply po 1000 kay para ma-convert into meter. Okay, so take note sa mga conversions ha. Kay dira po mo basig makakuan po mo dira sana masayop. So we have now 9.81 then 6371 times 1000 nya squared ni siya all over R diri, that is 6371 multiplied by 1000 plus 182 multiplied by 1000. So ang answer is 7795.11. So that is 7795.11, that is meter per second. Okay, pero ba okay ang sa ubos kay kama siya kilometer kilometer, then may mo siyang meter squared, then nabay meter squared. So sakto ma-cancel. So mo na siya ang ato ang value sa atong orbital velocity. So nga na class, again beware sa katong relationship nga at that particular R base ninyo gamiton nga G diri kung na siya nga height base ng G ra gihapon nga 9.81. Remember dili na siya 9.81 ara kay mo vary man ang atong G sa kanang sa gilayon sa object with respect to the center of the celestial body sa ato diri nga example kay ang Earth. Okay, so that's it and thank you for watching.